Hi guys, so in this lesson we're going to be doing dilations again, only this time we're doing dilations on the coordinate plane. Okay, so we're not going to be using compasses or constructions in this lesson. All right, so if you want to follow along on the handout that I provided, we'll take a look at number 1. So for numbers 1 and 2, it says find the image of each polygon after a dilation centered at the origin with the given scale factor. Okay, so in both of these examples, our center of dilation is the origin, right? So we know that the origin is the point 0, 0. Okay, so in both of these examples, our center of dilation is the origin. So the first thing I'm going to do is I'm going to graph my original triangle. So we got the point 2, 4. 4, 4, and 3, 2. Okay, so this triangle right here, JKP, is my pre-image. All right, and our scale factor is 2, so this is going to be a stretch. So our image is going to be twice the length of our pre-image, or twice the size of our pre-image. Okay, so when you're dilating with respect to the origin, all you're going to do is take the coordinates and multiply those numbers by the scale factor. Okay, so when dilating with respect to the origin, you're going to multiply coordinates by the scale factors. Okay, so here in this example, J prime, 2 times 2 is 4, and 4 times 2 is 8. Okay, K prime, 4 times 2 is 8, and again, 4 times 2 is 8, so K prime is 8, 8. And then P prime, if I take those numbers and I multiply by the scale factor, we're going to get 6, 4. All right, so we got J prime, K prime, and P prime is 6, 4. Right, so you should notice that this triangle is twice the size of the original, or twice the size of our pre-image. Okay, so that's dilating with respect to the origin. All right, we'll take a look at number 2 also. Okay, so first I'm going to graph my original triangle. So point D is negative 2, 0. G is 0, 2. And F is 2, negative 2. Okay, so that triangle is my pre-image. So now we're going to find the coordinates of the image. Okay, so here my scale factor is 1.5. So our image is going to be 1.5 times the size of the original. Okay, so it's still a stretch. It's still getting bigger. So again, I'm going to take every single coordinate and I'm just multiplying it by my scale factor. So negative 2 times 1.5 is negative 3. 0 times 1.5 is 0. Okay, G prime is going to be 0, 3. And F prime is going to be 3, negative 3. Okay, so there's our image, which is 1.5 times the size of the pre-image. All right. The other thing that I wanted to point out to you guys is we can also take a look at this in terms of the graph. Okay, so if you take a look at this first example, to get from O to P, you should notice that I'm moving up 2 boxes. Oops. We're moving up 2 boxes and to the right 3 to get to P. Okay, so up 2, right 3. So that's a scale factor of 1. So now to get a scale factor of 2, I'm going to double that. So I'm going up 4 to the right 6. Okay, so that's just kind of another way to think about this. All right. Question number 3 is a little bit more practice with this. So in this one, they asked you to graph the image after a dilation with a scale factor of 3/2 centered at the origin. So I think this is an example that you guys can probably try on your own. Okay, so I'm going to leave number 3 for you guys to take a look at on your own. All right, number 4. So in number 4, they have the pre-image and the image graphed for you, and it says describe the transformation that was performed. Okay, so right now the only transformation that we've talked about is a dilation. Okay, so this is a dilation because it's a stretch, right? Our image is bigger than our pre-image. All right, so whenever you describe a dilation, there's 2 things that you have to include. Whenever you're asked to describe a dilation, you have to include the center of dilation, and you have to include the scale factor. Okay, and the scale factor is always the ratio of the image to the pre-image. Okay, so first let's talk about how to find the center. So to find the center of dilation, we can do this the same way we did it with constructions. Okay, so what I'm going to do is I'm just going to take my straight edge, and I'm going to connect every pre-image to its corresponding image. So A to A prime, draw a nice long line. Okay, do the same thing with B to B prime, draw a nice long line. And C to C prime. Okay, so you should notice that all 3 of those lines intersect at the origin. Okay, so our center of dilation is the origin. Okay, you can also say the point 0, 0 because that's obviously the origin as well. All right, so to figure out the scale factor, we got to look at our coordinates. So you can use any pair of points that are the image and corresponding pre-image. Okay, so for example, point A had coordinates -2, 4. and that gets mapped to A prime, which has coordinates negative 5, 10. Okay, so our scale factor is always image to pre-image. So if I compare the y coordinates, 10 over 4 is going to simplify to 5 over 2. Okay, so our scale factor is 5 over 2. And if I use the x coordinates, I get the same thing, right? If I do negative 5 over negative 2, that also simplifies to 5 halves. All right, and the same thing would happen if I take a look at b and b prime, right? Point B was negative 2, negative 4. And then b prime was negative 5, negative 10. Okay, so again, if I compare the y values, negative 10 over negative 4 still simplifies to 5 halves. Okay, and the same thing would happen if we use c and c prime. All right, so here when it says describe the transformation that was performed, we're going to say a dilation centered at the origin centered at the origin with a scale factor of 5 halves. Okay? All right. Now in the next part it says explain why the image is similar to the pre-image. Well, we just stated that it was a dilation. So here we can say dilations preserve angle measure so the triangles are similar by angle, angle. All right, and angle, angle is one of the theorems that we talked about in the very beginning of the unit, right? Okay.